Okay, so we had a question about the connection between um, uh, the partial products algorithm and the modeling of using an area model to model the product between two numbers. Okay, so let's start off by looking at a number like, or a product like 243 times 87. So what we're going to do is basically look at the partial products algorithm as well as for this product, as well as the area model. So we know that at some point we can look at the area model for this and say that this product can be modeled geometrically as the area of a rectangle with side 243 and say base 243 and height 87. So for instance, okay, so this would be base 243 and height 87. I mean, no big deal there. That's easy enough. This is the concrete. Okay. So what we're going to do, let me blow this up a little bit. Let's say, so if this side is 243, so the base is 243 and the height is 87, then notice I can break this height up into, let's say, 80 and 7, right? And the base, I can break that up. And I'm doing this not just arbitrarily, but I'm doing this by place value. 87 is 80 plus 7. 243 is 200 plus 40 plus 3. So let's say 200 plus 40 plus 3. All right, now if I continue these distances, so that, let's see, one more. All right, so notice I've subdivided this big rectangle up into sub rectangles that are, there's one, two, three, four, five, six partial areas or partial rectangles that when put together make up the whole thing. All right, and the area here, point to it, is going to be 3 times 7. The area here is going to be 40 times 7. The area here is going to be 200 times 7. The area here is going to be 200 times 80. The area here is going to be 200 times 40. And the area over here is going to be 200. Oh, sorry, I've messed that up. Let me scratch that. Let me just go back by just a second. This is an 80 by 200 rectangle. So that was right. That was 200 by 80. This one, however, is 80 times 40. So 80 times 40, and this one is, see, this length is 200. This length is 3. So this is 80 by 3. All right. So now if we take each of these, so 200 times 80 is 1600. 1600. 200 times 7 is 1400. So I'm sorry, 200 times 80 is actually 16,000. 80 times 40 is 3200. And 80 times 3 is 240. And 3 times 7 is 21. Okay, so if we were to add up 21, sorry I missed one, let's see, 40 times 7 is 280. So if we were to add up 21 plus 280 plus 1400 plus 16,000 plus 3200 plus 240, we would get the whole area of this 87 by 243 rectangle. Okay, so it's very concrete at this level. So we're going from the concrete over to the abstract, and that's going to be our partial products, I'll say partial products algorithm. All right, so this is 243 times 87. So this is going to be 7 times 3 is 21. 7 times 40 is, I'm just going to go through this pretty quickly. 7 times 40 is, if if I can. 280. 7 times 200 is, let's see, there are going to be two zeros and then 1400. 80 times 3 is, well, it's 8 times 3 with a 0, so 240. 80 times 40, two zeros. 8 times 4 is, so 3200. And then finally, 80 times 200, that's three zeros, and then 8 times 2, so 16,000. We add these up, we get, let's see, so I carry the 1, 1 and 2 is 3, 3 and 4 is 7, 7 and 2 is 9, 9 and 2 is 11, so, alright, so 6 and 3 and 1 is 10, and 1 is 11, and the answer should be 21,141. This part here is not nearly important because what we're trying to do is look at the connection between the two. So notice that there's a 21 sitting over here, right there, that 21. And that came from when I multiplied the 7 times 3, just like when I had a 3 by 7 rectangle. This 280, that was from the 7 times 40, or right here. The 1400, there's 1400. So there's a nice connection between the concrete and the abstract. Let's see, I'll just draw these arrows just to show. And the last one. I know there's a lot of mixed up lines there, but you can see I can follow from the rectangular area model, which is again concrete, over to this abstract paper and pencil thing where we're just messing with symbols. We're writing these ones and carrying these ones over here, and adding all these up. But this is the math, and this is a representation of the math at the abstract level. So hopefully that shows the connection. These arrows, this is the connection. Between concrete and abstract. And this connection is super important. That's the reason why why this algorithm is better than so many other algorithms, because we do have that connection between the concrete and the abstract. So hopefully that answers that question.